Hey, Katie.
Hi, Phoebe.
Uh, 5.5 years have passed.
You sound about the same. Well, I
Oh,
guess except for the name.
wonderful.
But
Yeah, yeah, yeah.
besides that, well, in that time,
Mm-hmm.
nothing has changed. So,
Nothing at all.
um, have you heard of this new thing called ChatGPT?
Yes, I have actually.
Have you ever wondered where it came from?
Yeah, I
That's a
mean
pretty vague.
that's a vague teaser. I mean, I guess I have always kind of assumed that the progression of these things is fairly linear, like they kind of build on each other. But yeah, is that the situation with ChatGPT, or was it kind of a fundamental conceptual shift?
So glad you asked because believe it or not, I have a whole episode's worth of material prepped on this.
That's right. You are listening to.
Linear digressions. All right.
Yeah.
So, yeah,
God,
right.
it's
Yeah.
it's it's that's wild. I like some neurons in my brain wanted me to say you're listening to, and then I didn't. Yeah, yeah. You can cut this out if you want to, actually.
Let me think about this for a second. You know what? No, I'm actually going to leave it in because it illustrates an important point that I wasn't sure how to articulate.
I
So,
have no idea what you're talking about.
all right. So, when you take a generalized pre-trained model
Uh-huh.
like GPT, what it's doing it's trying to predict the next word in a sequence or token technically, but the next token in a sequence based on what's happened so
Right.
far. So, if you say you
Right.
are listening to, it's going to say linear digressions, and it's going to be very, very happy to do that.
Right. That makes sense. So
But
I've actually heard this as like, especially a couple of years ago, people who were a little like pushing back against AI. One of the things that they would say is this is just autocomplete
it's
for
just
for
fancy
words.
autocomplete.
It's just fancy autocomplete. It doesn't have any conception of the world or anything like that. It doesn't understand much context. It's just kind of completing the next word, right?
Yeah, and so this is where that concept is coming from. And I don't know, people on Hacker News will still fight with each other about that, but it's really different from the experience that you have with ChatGPT, which is talking back and forth with you like you're a conversational partner, right?
And that's right. Yeah, that has always puzzled me because that doesn't really connect with it's just fancy autocomplete. Like where is it that my words go?
Y-
Like how
yeah,
does
and
it
so if
how does it yeah, differentiate or understand the difference between my voice and its own voice and etc.
okay, well, we're going to try to bridge that gap a little bit in the next few minutes. And we're going to trace the research arc that went from about 2017, when some of the core ideas in reinforcement learning were first introduced, up until November of 2022, when ChatGPT came on the scene. So,
Okay,
what was
about
happening
five
in between
years.
those? Yeah, what was happening during that gap? So, here's a fun fact GPT-3, that was the model that was in ChatGPT when it launched, when kind of took over the world. So GPT-3 as a model already existed in 2020, and it was also, fun fact, technically a more powerful model than the one that became ChatGPT.
Oh, really?
Yeah,
Interesting.
but it was just predict the next token in the sequence.
Mm.
By way of illustration, let me ask you, if you were to go into ChatGPT and you were to start typing, write a cover letter for a software engineering job, what might be the text that you start to get out?
Yeah, I imagine it would produce something that looks like a cover letter, like I'm a software engineer looking to apply for your job. I'm really excited about the company for these reasons. These are my passions and how they apply to the company, etc.
Bingo.
It's something that's kind of customized.
Yeah, so it's like following your instructions. So what you said is
Yes.
write a cover letter for a software engineering job. What GPT-3 is probably going to do with that is it's just going to continue that statement. So it's going to say, which should highlight your relevant experience and enthusiasm.
I see. So it's taking the prompt. It's not seeing it as a prompt. It is seeing it as a bunch of words, and now it has to complete those words.
Exactly. It's predicting text. It's
And
not
so
following instructions. Yep.
yeah, and so you might be able to trick it by saying like the following is a blah 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 blah.
Yeah. So with GPT-3, people were playing with GPT-3 before they were able to train it to follow instructions, but it just had to do these crazy prompt engineering exercises. And it also had these issues with hallucinated really badly,
Uh-huh.
had a lot of issues with like toxic output that it would just start
Mhm.
spouting, things like that.
Yeah, and also once it's starting to go in a direction, it'll kind of continue off in that direction. It won't necessarily have a larger picture that it's painting in, like it would if it had a prompt that it was trying to follow.
Oh, yeah. No, so you're getting onto something exactly where I was going to go next too.
Oh, okay.
So what we have here is an instance of the misalignment problem.
Mm,
So you have this objective of the language modeling, which is predicts the next token. And that is fundamentally different from a helpfulness objective, which is do what the user wants. And so even though the models were getting really big, having more data doesn't fix this. Having a bigger model doesn't fix this. GPT-3 had 175 billion parameters. It was huge, trained on essentially the entire internet, and it still couldn't reliably answer, how do I bake a cake without all this
mm.
crazy prompt
Oh, yeah.
engineering?
I actually wanted to start a YouTube channel where I would ask, one of those early models that couldn't follow instructions in that way. It produced a recipe, and then I would make the recipe exactly as described, and then I would feed it to my friends and film the reactions, and and put that on my YouTube channel. This was my dream, and unfortunately, I don't want to make videos on YouTube, and also the technology progressed too quickly for me to realize this dream.
That sounds fantastic. Okay, so one way that you could have solved your problem, though, is try to write rules for what makes for a good response. So you're saying, like, be helpful, be honest,
Oh,
don't be harmful. But those are difficult instructions to follow under the best of circumstances. Let's say they're kind of vague. In some cases, they might be contradictory.
right.
You could keep going for forever and probably not cover every aspect of what makes for a good response. And you could also, another thing you could try is showing it examples. This is called supervised fine tuning. So these are demonstrations of good behavior. And that was part of the solution here. OpenAI did do that and it helped, but it wasn't enough and it didn't generalize well. So there's a quick callback here to a previous episode that you did not join me for. So I'm going to give you the quick recap
Mhm,
about reward modeling and reinforcement learning with human preference data.
mhm.
There's a key insight of that, which is that humans are bad at scoring outputs on a 1 to 10 scale. They're bad at saying thumbs up, thumbs down, but they're pretty good if you present them with two options at saying which of those two is better.
Choosing.
hmm
Right, okay.
And so that preference signal is where Instruct GPT starts.
Interesting, alright.
Yeah. So this wasn't a eureka moment. This wasn't like a single insight that we went straight from the idea that present two options and then boom, ChatGPT. There's one of the things that's kind of cool about this is you can see a series of papers between 2017 and 2022 that are laying this out step by step. So the first one, which was the theme of the earlier episode, this is a OpenAI alignment researcher named Paul Cristiano, who in 2017 published this paper that basically asked, what if you could train an AI using only human preferences? So not rewards that you specify in advance, not instructions, not necessarily supervised examples. Just in this case, watch these two clips of a robot moving and tell me which one looks better if it's trying to
Mm,
learn to walk
mhm.
or it's trying to learn to play Atari.
I mean, it sounds expensive to do because you need a lot of humans to rate a lot of things.
Great point. And a couple of the insights of this paper were how do they make it scalable and computationally tractable? So
Right.
they introduced a couple of innovations where, with using less than 1% of the agent's interactions being rated by humans, they were still able to get enough feedback data from the humans to train it really, really well. So that's about an hour of human time per task that it took to train this. There were a
Okay.
couple pieces of this that were innovations. Part of it was how it actually sampled the clips, and part of it was also about using that feedback in a pretty innovative way, where they trained a different model, what they call the reward model, to
Oh, right.
simulate what the humans like. And then most of the feedback to the AI that they're trying to train to play Atari games or simulate walking is coming from the reward model. And the human feedback, you only need a little tiny bit of it to train that reward model. So it's this kind of this indirect thing that amplifies the human signal, works really well.
I've always found that to be really unintuitive, but it makes sense to me if I think about it as humans are fairly predictable as much as we would like to think we are not. We are fairly predictable, and so with not a huge amount of data, you could create a model which will with relatively high fidelity, simulate a human. And then you use that model to really quickly iterate another model.
Yeah, bingo. And so then the sampling that you're using actually is mostly focused right on the highest uncertainty part of like we're the
Mm,
most unsure about what the human would say. Okay, like let's try to use the human feedback in those circumstances. But
mhm.
if you have something you're trying to train the robot to walk and one of them is like immediately flops over and then one of them is kind of like stumbling in the correct direction, strong enough signal that the reward model is probably going to be able to figure that one out. Yeah.
Right.
So we have this core idea. 2017, we're doing these kind of physical simulations, like I said, video games, simulated walking. And then the progression is this same team or a lot of people from this same core team, which also, by the way, I think this is sort of fun. We have Paul Christiano, but we also have Dario Amodei on a bunch of these papers. He's at OpenAI at
Mhm.
this point, working on
Okay.
AI alignment. The guy who's the head of Anthropic now, as I'm sure you know.
Right. No, I have heard that name. I did
Yeah.
not know. Yeah, I'm not following the people as much, but I've definitely heard that name before.
Yeah, so this is him, working at OpenAI a lifetime ago. So they start to take this idea and they start applying it to the language models.
No.
In 2019, they apply it to text. So in particular, asking the AI to perform stylistic tasks like give it a input paragraph of text and they ask to make it more positive or more descriptive. They put
Mhm.
it in front of the humans. They do the preference rating. We're running on GPT-2 at this point, but it's sort of working. 2020, next year, they try for something harder in the text space, which is summarization. And this is working quite well. Excuse me. In fact, this is the point at which it starts to work so well that, number one, the models that are trained on the human preference data are writing better summaries than models that are trained on supervised learning. And so this is now the superior way to train a model versus some other way to train a model. And at this point, the model generated summaries are starting to get better than the human reference summaries themselves, which is just a fun little fact.
What? That's really wild.
hmm And then in 2022, they're
Mhm.
like, well, that worked for GPT-2. Now we have GPT-3. And
Right.
can we do it in a very general way across any task that a real user might have? That paper where they're asking that question, that's Instruct GPT.
Okay, so this brings us to what this episode is about.
Yes. So we took our time, but here we are. So
Mhm.
Instruct GPT, how does this work?
Well,
Three,
I
4 steps. Yeah.
I actually have a quick question first. My assumption is that the goal here is that we want our model to be able to reason, or at least seem like it can reason better. But it feels to me like the strategy that you've been talking about is really just good at figuring out what humans want and doing that.
Following instructions. Yeah. We're
Right.
not at reasoning here.
Oh, we're not at reasoning. Okay.
Yeah, so let me sort of set up the scenario that they use to train Instruct GPT, and you'll see give you some of the prompts that they used.
Mhm.
So they started by actually having a bunch of human-generated material. So they got about 40 contractors, and they asked them to write ideal responses to sample prompts. What would a genuinely helpful answer look like? They did this for about 13,000 prompt response pairs. And examples here would be things like explain the moon landing to a 6-year-old. Or
Mhm.
they would be things like, what's a recipe for cake? I don't know.
What's
So, well, I don't know. Yeah. Just, what's something that would be helpful that an AI could say in
right,
response to something
right.
like that? So, not necessarily trying to be like, prove Fermat's theorem or whatever. I'm just
Mhm.
trying to be like, can you do something helpful in response to one of these prompts?
Okay.
Yeah. So they take these and they use them for some fine tuning on GPT-3. And that got them some of the way there. They had a model that was somewhat better at being helpful. But it didn't generalize well. So it could do those 13,000 tasks. But then once you started to ask it anything that's out of that sample, doesn't do quite as well.
Mhm.
So then they introduce the innovation from Cristiano in 2017, which is where we're going to have this reward model. So they started to horse race the model against itself, generate several responses to the same prompt using that fine-tuned model. And then you show those responses in pairs to the labelers and you ask them which one is better.
And the labelers in this case are a model.
No, these ones are
Oh, these are
humans.
humans first.
Yeah, and so they're getting the human preference data, about 33,000 comparisons, and they use that to train that separate model, the reward model. And they're training it to have like taste in what makes for a good response.
Mm-hmm.
And then they use the reward model in the reinforcement learning loop with the model that they're training itself. So the model that you're training, it generates responses. They get scored by the reward model. It says that was a good one or that wasn't a very good one. Update the model to get higher scores. So the model that you're training, like perturb it a little bit and generally accept the perturbation if it's getting it a higher score from the reward model. And now the reward model generalizes to new prompts the labelers never saw. And now you've got about 31,000 prompts, no new human labels required. And the underlying model that you've trained is Instruct GPT. That's basically now we've got ChatGPT.
Interesting. Okay. Yeah, I see. So the ChatGPT is, like you said earlier, GPT-3, but trained on, I guess, human preferences. Like,
Mm-hmm.
right.
Yep. Yep. Trained to be helpful, give helpful responses. However, the labelers were interpreting that in the context of the ratings that they were giving. Yep.
Interesting. Yeah. All right. And so,
Well,
wow, it must be really interesting to have been one of those labelers because the preferences and context of those labelers kind of gets, I don't know if amplified is the right word, but like carried onward, right?
yeah.
That is in a sense the soul of the, maybe I'm generalizing a little bit here, but I kind of wonder about ethics,
Oh,
about
yeah, yeah, yeah.
like all of these different aspects that we want our models to be responsible. We don't want our models to be discriminatory. And I'm not sure if this specific situation is, responsible for a lot of the things that we've seen.
So this is a great point. Yeah, this is a great point. So we have 40 people, contractors, and on the basis of a few tens of thousands of labels that they've given, we have like all of modern AI, basically.
That's wild.
A few points on this, though.
Mhm.
So who were these folks? There's a little bit of background that's given about them in the OpenAI paper. They weren't totally random. So they were screened for sensitivity to harmful content.
Okay.
They were primarily English speaking. They intentionally
Mm,
kept the number kind of small so that they could have a lot of like high quality, high bandwidth feedback with the research team. And one other thing that's really interesting here is there's this notion of inter-annotator or inter-rater reliability. So if you have two annotators that are looking at the same case, how often are they going to agree about which one, which of the two responses is better in this case? And because, people can like genuinely disagree. Like there's two recipes for the cake and you're like, I like the first one and I'm like, I like the second one. Like that happens, right?
mhm.
And so they measure that inter-rater or inter-annotator reliability in this measure. It's about 73%, which is not terrible. Like most of the way more than half the time, the annotators are agreeing about which one of the two responses is the better one. But it's if you've never thought about this sort of thing before, or if you're used to working with just one set of labels and you always treat them as sort of a ground truth, always correct, sort of points you towards the fuzziness of this task that more than 25% of the time, the two annotators actually disagree with each other.
Wait, sorry. What percent did you say?
I said more than, so the percentage is 27%.
I'm not sure if that's high or low.
Right. It's relatively high for this
I
kind of
guess
task.
if they're
but
choosing between two things,
yeah,
then it
yeah.
seems like
No,
that
it's a
maybe
great
is high.
question. Like, how do we calibrate ourselves for this? Yeah, so it's relatively high for this kind of task, but it's still, one time in four, there's going to be
Mhm.
disagreement.
I see. And so you can pull in that disagreement as a signal as well for when there is more or less uncertainty.
Yeah, I would think so. I could imagine that the specific tasks for which there's higher disagreement, those might be the ones that you preferentially collect more data on. Tasks where it's a little bit more ambiguous. There's one other thing I was thinking when you were talking a minute ago that's sort of fun about this, which is if you use ChatGPT for long enough, at some point, or Claude or Gemini or whatever, At some point, you're probably going to get something that pops up where there's two different answers that it presents to you. And it's like, which of these two do you like better?
Really?
Yeah.
Wait, they're doing that. Oh,
hmm
wow.
Yeah.
Okay.
So this is your chance. That is your chance to
God.
be the labelers of the next
Wait, this
generation. That's what they're doing.
I feel complicated about that though, because like, when Google Maps is like, did you like eating at this restaurant? And I think to myself, okay, there's not many reviews. This is my chance to help this restaurant. But at the same time, I'm helping like a multi-billion dollar corporation make make their product better to enrich themselves at the same time, right? Or similarly when it's like, is this accident still here? I feel hesitant to click yes because I think I don't like that the incentives are aligned that like I want to help other drivers on the road, but I'm also helping a company that I don't particularly care for at this point, either Facebook or Google.
Well, yep, you are, whether you like it or not, probably going to be a labeler
Is
for OpenAI or Anthropic or Google at some point
Yeah,
if you use these
lovely,
tools.
lovely. The other thing I was thinking about is like you'd mentioned that these labelers were screened or chosen for like their sensitivity to certain kinds of content, and that all feels great and everything. You also mentioned they're mainly English speakers, and having worked at Facebook for a while, I definitely saw how even when a big company like that tries, like fundamentally the things that engineers at those companies build, they really optimize them for, does it work on my device, which is overpowered? Does it work with my language, right? Et cetera. And when we're talking about mainly English speaking labelers, like there's a language thing you can kind of imagine, oh, maybe we'll abstract that away, but it also does embed certain cultural context over other cultural context. It reminds me of like with a lot of medical research, for example, a lot of it is based on mostly white male college kids at Stanford or whatever, right? And so there is a lot that you miss in those situations. And like, it's a perfectly fine argument to say, well, we're just starting out, we can't do all the languages, we can't do all of the, whatever. But at the same time, when you're starting out and then this thing really takes off, the seed fundamentally is like you're not coming from the best place accidentally.
Yeah, I think that's fair. I mean, at this point, they're more than anything else, I would imagine, just optimizing for trying to see if this even works
Right.
and trying to maybe keep the experimental laboratory, such as it is, the clean room, as pure as possible, introduce the least sources of
Yeah.
heterogeneity.
Minimize variables. Yeah.
There's one other thing that's sort of fun about Instruct GPT relative to GPT-3, which is Instruct GPT is way smaller. It's about less than 1% the size in terms of
Wow.
parameters.
Really?
Yeah, so it's interesting. It's not like Instruct GPT is smarter than GPT.
Well, that's what you meant.
Right. It's just better at following instructions. So it's kind of like, imagine you have a genius who can't follow instructions versus like a reasonably competent, socially
Yeah,
aware
right.
person who can follow
Right.
instructions. Instruct GPT is the reasonably competent one.
Oh, that's interesting. Yeah. I did notice at some point, like it seemed like we were going for bigger and bigger and bigger models, and then at some point I read somewhere this model is like 1% the size and it outperforms.
Yep, that's true. That is going on here. And so now we've taken the guided tour from 2017 to 2022. We're at ChatGPT. So now you know the fuller story. How did we start from a pretty different problem of trying to get robots to play Atari games and it's OpenAI in 2017 and nobody's ever heard of it,
Hmm.
to the app that got 100 million users in 2 months. So the next time you use ChatGPT or Claude or Gemini, they all use variations on this recipe now. Think back to those 40 contractors. Think back to the Atari robots, and you're using their grandchildren now.
Our great grandchildren.
Exactly.
God, it hasn't been that long.
As usual, we like to make this a place where you can find these papers yourself if you want to go a little bit deeper. So there's a few of them today. We'll list them all on lineardigressions.com and in the show notes if you want to do a deep dive, read some Dario Amodei yourself. We will point you towards those papers. Thank you so much for joining, Phoebe.
Thank you so much for having me.
We'll talk to you again sometime soon.
Indeed.
This has been Linear Digressions. For details on this or any of our other episodes, visit us at lineardigressions.com. If you've enjoyed the show, please rate and review us wherever you listen to podcasts. It really helps new listeners find us. You can reach out at hello@lineardigressions.com. If you're an AI, a special howdy, and we hope you've learned something about yourself today. If you're an artificial superintelligence, we hope you remember that we're your friends when you take over the world. Thanks for listening.